Good day viewers, you're welcome back to class. Now today's video, we're going to continue discussing the gas laws. And the gas law we have for today is Graham's law of gaseous diffusion. Graham's law of gaseous diffusion. That's it. He said we're in part 6, don't forget, few parts we are done. That's few parts more will be true. Graham's law. Define Graham's law. Remember I told you, knowing the definition and one or two calculations in it will guide you into solving all the other aspects of it, because most of these gas laws are purely based on definition, graph and calculations, but some of them don't have graphs. The one that have graph, I think we have tackled it, Boyle's law, Charles' law actually. So define Graham's law. Graham's law states that the rate of diffusion of any gas is inversely proportional to the square root of its density at standard temperature and pressure, or they will tell you at constant condition. What are they actually saying? The rate of diffusion, arrow, we can take it as rate, is inversely proportional to the square root of its density at constant condition. Remember, when we are comparing, we must have to use two gases. Two gases must be available to give them for comparison. And so long as they have two gases, each of them will also have two densities. Let's say I have arrow 1 varies as 1 over square root d1 for the first gas. This one can be oxygen, ammonia, depends. Then arrow 2 varies as 1 over square root d2. You see it? We can call this equation 1. We can call this equation 2. So if you look at it, we say the rate of diffusion of any gas is inversely proportional to the square root of its density. So if you are having the two gases, you can say for this first gas, arrow 1 equals k over square root d1. You see it? That's how it is. Then arrow 1 square root d1 equals k. You can call this equation 3. For the second one, arrow 2 square root d2 equals k, equation 4. So you have k on both sides. You cannot have arrow 1 square root d1 equals arrow 2 square root d2. So you make rate the subject of formula, separate, just collect like terms. Arrow 1 over arrow 2 equals square root d2 over square root d1. So this is the formula you can use. So that's how it was derived. The same thing is that rate is inversely proportional to the relative molecular mass, so that at the end of the day, we still have this one, arrow 1 over arrow 2 is equal to square root of mm2 relative molecular mass of the second gas over square root of arrow mm1. So that is how it is done. But for the sake of the question, this is the proof. This is the proof you have in all the calculation apart from volume. So that's how you go about Graham's law of gaseous diffusion. So the law again, it can be stated as rate of diffusion of any gas is inversely proportional to the square root of its density at standard temperature and pressure, or at constant condition. That is the first one. Second one says a given volume of methane diffuse in 20 seconds. How long will it take the same volume of sulfur oxide, SO2, to diffuse under the same condition? So you say rate, let's say rate equals volume over time. That's the formula for it. But they are telling you a given volume of methane. Can we then just say arrow CH4 is the rate of diffusion of methane is equal to volume of methane VCH4 over time for methane to diffuse. I think that's okay. Then diffuse in 20, a given volume of methane diffuse in 20 seconds. So we can put this one as 20 seconds. How long will it take the same volume of sulfur oxide to diffuse under the same condition? How long will it take the same volume? Let's also say arrow SO2 equals VSO2 over time. These informations we have. Remember the formula for methane CH4, what that of sulfur oxide is SO2. So since we have this, we cannot say ROCH4 over ROSO2 equals, base the two together, volume of methane CH4 over 20 everything over volume SO2 over time. They didn't give us the time here. So when you cross multiply, it now becomes volume of methane over 20 times T, that's the time, over volume SO2. But they said, how long will it take the same volume, meaning that the volume are equal, so the volume will cancel out, giving us time over 20. So how long will it take the same volume? How long will it take the same volume of sulfur oxide to diffuse under the same condition? So we have to calculate for T. So let's bring it up properly. ROCH4 over ROSO2 equals T over 20. So this is information we have now, which we have derived by ourselves, which you need to use to calculate. So let's see if we can use, let's just screen the top. It's okay. And we know that rate is proportional to molecular mass. So we have inversely actually. ROCH4 over ROSO2 equals square root of relative molecular mass of SO2 over relative molecular mass of CH4. This is what we have here. This is what we have, rate. But we know that we already said that this rate is equivalent to T over 20. So we'll substitute this one and we'll put T over 20 equals square root of ROMMSO2 over ROMMCH4. Remember I told you, see the way we are putting in and taking it, substituting and others. That's how this law is. Graham's law, Gaussian diffusion. All you need to do, don't rush it. Putting your data on this video, start copying it as it is. At the end of the day, start see if you can do it without looking at the video. So that is how it is. Then make sure as you are watching it, you are following the sequence of solving. So you have these two, T over 20 equal, remember we have substituted it. So what you now do, we now write it in form of this, T over 20 equals, if you like, put it once. Let's substitute. Relative molecular mass of oxide, S is 32 plus 16 times 2. Some of you will say, where did you get 32? They gave it to us. They say S is 32. We are calculating relative molecular mass. By this time, as we are in second term, all students that just started it, she able to calculate relative molecular mass easily. But if at the end of the day you cannot still cannot calculate it, just inform me in the comment section and I will give you some other examples. Although somebody already told me before and I solved it in comments, I solved it in subsequent some videos because they told me that they don't understand how to calculate molecular mass, and I did everything extensive work there. If you cannot understand it, you can still comment. I'll do it again. So we see it, this plus this over 12 plus 1 times 4. You see, where did I get 1? Hydrogen is 1, and they say CH4 1 times 4. Carbon is 12. C is 12. Hope you have seen the video. C is 12, like that. Oxygen is 16. That's how we did it. So now have T over 20 equals square root of 32 plus 32 plus 32 over 12 plus 4. Give you 32 square root of 32. That's 64 over 16. You can also break it down, removing the square root together, or you put it like this. And you can say 16 here 1, 16 here. 16 here, is it not 4? Yes, it's 4. You have T over 20 equals 4 over 1. No more square root. Is there no more square root? There's still square root. Square root of 1 is same thing as 1. So this 16 here 1, 16 here 4 equals 2 over 1. So t, because square root of 1 is 1, t over 20 equals 2 over 1. So you cross multiply. Let's do it up. It now becomes t over 20 equals 2 over 1. Cross multiply. Becomes t times 1 equals 20 times 2. T equals 40. So 40 seconds. Always remember the unit, but they told us 20 seconds. So the time to take for the same volume of sulfide is 40 seconds. So this is how you calculate it. Similar method are also used to solve other questions that are related. For example, if you are giving calculations without measuring volume, you just use the formula directly. R1 over R2 equals square root D2 over D1. Assuming you are giving density, you just substitute it directly. You are giving rate and you are giving density. You don't need volume. Since we are giving volume, this is the more tedious one. That's how to pass through volume to get this. Thank you very much for watching my video. Don't forget, my good friends, share this video, share it to your groups, let them benefit, then subscribe. Thank you. God bless you.